Welcome to Easy Anatomy. I will discuss with you now venous drainage of brain. Venous drainage of brain. Okay. I will demonstrate this by two simple drawings. One for the superficial veins. So here is the lateral surface of the brain. Okay, and then we'll have a kind of coronal section to show the deep veins. Here is caudate nucleus, and thalamus, thalamus from the other side, and the caudate nucleus also from the other side. Then you remember that we have the fornix and the mammillary body. Then down here is going to be the crustopry and midbrain. So let me again, this is fornix, mammillary body, caudate, thalamus, this is the lateral sulcus. So superficial vein, we have superficial veins, and deep veins, Okay, the superficial veins, you have the superficial middle cerebral vein, you have the superior group, okay, you have inferior group, and there is always communicating veins between the three. So you have superior, middle, and inferior. Superior, middle, and inferior. The superior usually communicate and end up into the superior sagittal sinus. So here, superior sagittal sinus. The middle usually is going to drain into cavernous sinus. The inferior is communicating with transverse sinus. This is a superior sagittal sinus, if you remember, is going to continue as transverse, right, mostly right transverse. This is transverse sinus. This is superior sagittal sinus, and middle cerebral vein go to cavernous sinus. The inferior going to transverse. So the inferior drain into transverse sinus, superior drain into superior sagittal sinus, in middle cerebral vein, the superficial middle go to cavernous sinus. Okay, we're done with the superficial veins. Coming to this veins related to corpus striatum. Remember that caudate, internal capsule, and with lentiform nucleus outside here, usually they form the corpus striatum. You will find that we have a striatal vein or thalamostriate veins, coming from the caudate and thalamus, and they joined by another group of veins which are choroidal veins, and all of them they join each other and they form two internal cerebral veins. Two internal cerebral veins, right and left, internal cerebral vein. So the internal cerebral vein made by the thalamo straight vein and choroidal vein. Okay, they form internal. The internal cerebral veins are joining each other to form great cerebral vein. Great cerebral vein or vein of Galen. Sometimes we call it Galen vein. Okay, what happened next? The great cerebral vein, this great cerebral vein is going to be joined by inferior sagittal vein to form straight the inferior sagittal sinus, inferior sagittal sinus to form straight sinus. Again, it's very easy now. If we start from the top, we have thalamostriate vein joined by choroidal vein. They form internal cerebral vein. Internal cerebral veins together, they form great cerebral vein. The great cerebral vein is going to be joined by the inferior sagittal sinus to form straight sinus. And you know what happened to the straight sinus? Straight sinus later on is going to continue as transverse sinus, mostly the left one, transverse sinus. Okay, so let me ask you this question: what is the final destination? As you see, cerebral veins are ending into dural sinuses, like the superficial veins going to superior sagittal sinus, transverse sinus, cavernous sinus. And then you have here the deep veins are going to end into straight sinus, then transverse sinus. I will take you back and ask you what transverse sinus, since this is the final destination up to this point. Transverse sinus, as you see the superficial vein going here, the deep veins again going here, so we have right and left transverse sinus. Each of them will continue as sigmoid, then sigmoid continue as internal jugular vein. So this is going to be sigmoid sinus, the right one, and this is going to be, this is right sigmoid, this is left sigmoid sinus, sigmoid sinus. What is next? Then they go to internal jugular vein, and this is also internal jugular vein. If you have the skull in hand now, try to look at the jugular foramen in the base of the skull. You will notice something interesting, that most of the time the jugular foramen in the right side is going to be larger than the left one. Why? Because superior sagittal sinus is usually larger than the inferior sagittal, larger than straight, and the straight will continue as left internal jugular, and later on the right transverse sinus will continue as right internal jugular vein, which is bigger. Okay, so this is just anatomical feature you might appreciate. If you go to the base of the skull and look at the jugular foramen, you might find the right jugular foramen is larger, because in most of the time the right jugular foramen or right internal jugular vein is a continuation of the right sigmoid, which is coming from superior sagittal sinus. Okay, so this is the venous drainage of the brain in short. We still have only one vein, which is called basal vein, which end into the internal cerebral vein. Those are basal veins. The basal veins are made by deep middle cerebral vein. Okay, the deep middle cerebral vein and the other veins join together and they form basal vein, and the basal vein end up into the internal cerebral. Okay, let me take you to one important thing. Most of the time we focus on stroke as obstruction of cerebral veins, cerebral arteries. Keep in mind also cerebral veins can be of clinical importance. Why? Because of venous thrombosis and arteriovenous shunt. Okay, can be clinical importance for cerebral veins. Let us go to circulation of CSF. Now I am taking you to cerebrospinal fluid. Cerebrospinal fluid. Cerebrospinal fluid, what is the function of cerebrospinal fluid? First of all, reduce the weight of the brain from almost 1400 gram to 25 gram, almost reducing the weight of the brain 60-fold. Reduction in brain weight. Okay. Second, it is a caution. So protect the brain. Protect the brain and the spinal cord. Third, metabolic buffer. Okay. Fourth, taking over the lymphatic function. Lymphatic of brain. If you remember, you cannot find any lymph nodes inside the cranial cavity. So lymphatic function is taken over by CSF. So immune function, metabolic buffer, caution, and reduction of the weight of the brain. So CSF is formed in ventricles site. It is produced, 60% of it is made by 60% of CSF made by choroid plexus, and about 20%, 30% by capillary bed, and also metabolic water 10%. So basically CSF formation, you have choroid plexus, okay, and this is 60%. Then the second source, capillary bed, about 30%. Then the third source is metabolic water, about 10%. So mostly it is made inside ventricular system, of the brain. You have lateral ventricle, you have third ventricle, you have fourth ventricle. In each of them you will find the choroid plexus. Blood supply of choroid plexus, if you remember, you have choroidal arteries, anterior choroidal artery, and also there are some choroidal arteries coming from, if you remember, coming from the anterior cerebral, middle cerebral, and the internal carotid artery. So, and the posterior cerebral arteries. And the source of those arteries in general, choroidal arteries in general, you will find that internal carotid artery, anterior cerebral artery, middle cerebral artery, and the posterior cerebral artery. So all of them, they form choroidal arteries. Okay, so this is just a quick reminder of the choroid plexus. Choroid plexus, those are located inside the ventricular system and receive blood supply from different cerebral arteries. Okay, let us go to circulation of CSF. The circulation of CSF is going to start from lateral ventricle and end up into circulation, into systemic circulation. How this happen? Let us go slowly and describe it using simple diagram. Here is the brain, the cerebral hemisphere. And here is the lateral ventricle. Okay, the same on the other side, and here is the lateral ventricle. Okay, then brainstem until you reach to the spinal cord. So the lateral ventricle, inside it is a cavity of cerebral hemisphere. There is a foramen here, it's called interventricular foramen. So this is lateral ventricle, and this is interventricular foramen of Monro. Sometimes we name it foramen of Monro. Then this is the third ventricle. This is the central canal. This is the fourth ventricle. This is the center canal of spinal cord. Center canal of spinal cord. Okay. So if we remember, we find that superior sagittal sinus is located here. Superior sagittal sinus. The brain is covered by pia mater. Okay. The pia mater. Then what is next? After the pia mater, the outer layer is choroid. Here is the choroid. Then you have the dura. The outermost layer is what? Is the dura. The choroid project into the superior sagittal sinus and choroidal villi. So this is choroidal villi. Okay. So this is dura. This is arachnoid. This is pia, and this is a subarachnoid space. This is subarachnoid space. So the subarachnoid space contains the CSF. So the CSF is made here in the ventricular system by the choroid plexus going to subarachnoid space. So once it's going to subarachnoid space, it's going to be filtered into superior sagittal sinus, correct? This is part of the drainage. So here is the subarachnoid space containing the CSF. You have also choroid plexus in the fourth ventricle, the drainage of the fourth ventricle, and the drainage of the lateral ventricle. If you remember, we have also the foramen of Monro or interventricular foramen. So CSF coming through here to the third ventricle, then through central canal to the fourth ventricle, and from the fourth ventricle you have three foramina, two lateral foramina, Floschka, foramen of Floschka, and also there is central foramen of Magendie. They take this to the subarachnoid space. Okay, so subarachnoid space again, if you remember, the choroid plexus will form CSF in the lateral ventricle, circulating out of the lateral ventricle, going through foramen of Monro or interventricular foramen to the third ventricle, central canal, fourth ventricle, and then from the fourth ventricle it has two directions, to subarachnoid space through the three foramina of Loschka and foramen of Magendie, and the portion of it go down to the central canal of spinal cord. Okay, so we need to keep in mind, and through the subarachnoid space, as you see the circulation, once it comes to the subarachnoid space, is going here circulating until it reaches to arachnoid villi and drain into superior sagittal sinus and go to superior sagittal sinus, and from superior sagittal sinus, where it go next? Superior sagittal sinus, it end up to the systemic circulation, internal jugular vein. As I mentioned, superior sagittal sinus will continue as transverse sinus, internal sigmoid sinus, then internal jugular vein. So this is very simple for this demonstration of circulation of CSF. So if you want to summarize it, from lateral ventricle, then you have to third ventricle, then central canal, then fourth ventricle, and from the fourth ventricle you have subarachnoid space pass to that, or central canal, and also central canal of spinal cord. From subarachnoid space is going to where? To superior sagittal sinus through arachnoid villi and the granulation. Okay, so this is the circulation of CSF. Any obstruction, one common site for obstruction, especially congenital, if there is obstruction here, what is going to happen? Accumulation of CSF leading to what we call it hydrocephalus. Okay, so hydrocephalus may result from obstruction of central canal or obstruction of the circulation, lead to accumulation of CSF, enlargement of the skull, and this is one clinical problem may happen as a congenital anomaly. Okay, also keep in mind this CSF circulate down to the central canal of spinal cord, and you need to pay attention if you wanted to take sample from CSF, you do spinal tape. Spinal tape where you can aspirate CSF from the subarachnoid space around the spinal cord, usually between third and fourth lumbar vertebrae, sometimes below the level of spinal cord. Remember that the spinal cord end up at the at which level? At the level of lumbar 1, so you need to be below the level of spinal cord. Okay, thank you.